Okay, the next problem I'm going to look at is problem 3. And this one is this, uh, where you have a shaft rotating at 1200 RPMs, revolutions per minute, and it experiences a constant torque. We don't know how much work the shaft does in 1 hour. Okay, all right. So this problem is actually relatively straightforward, and there really isn't much. There is one part we need to figure out, and that's the actual number of revolutions. But so I'm looking for the shaft to work. I wrote it WSH should be in 1 hour. And here's our angular velocity, they call it. This is omega, that's commonly used. And this is giving us in terms of revolutions per minute. Okay, so it gives us revolutions per minute, and we know that this is like total number of revolutions. So we would need to make that to figure out how many revolutions. If you had 1200 revolutions in a minute, in 1 hour or 60 minutes, you have 60 times that essentially, right? Um, the other part is now we have torque. This is the torque being applied, Newton meters. Okay. Here's the equation for our shaft work: 2 pi times n times tau. So really, it's a pretty straightforward calculation. We're given tau, pi, 2. We know those, so we just don't know what n is. We just have to figure out what n is, and we do that just by saying, oh, okay, make the conversion from minutes to hours and multiply it times hours because it's only 1 hour. Okay, so we make conversion to, how many revolutions in 1 hour is going to be 72,000. Multiply it times an hour because that's how long we've gone for, and it comes out to be 72,000 revolutions total. Okay. Plug it in, perform the calculation, you come up with 27.1 times 10 to the 6 Newton meters, which essentially is just, which a Newton meter, of course, is a joule, and this is going to be equal to 27.1 megajoules. And that is basically that one.